Hello everyone. Welcome to today's presentation. Today, we will be talking about motors, specifically electric ones, and why our lives involve them more than we would ever realize. Electric motors are all around you every day, from the hard drive in your computer to the CPU cooler in your computer that lets you play games, and even the cars that put you in your seats with a sub 3 second 0 to 60 acceleration. From the washer and dryer to the ceiling fan and even electric trains that allow for fast and efficient transportation to happen, electric motors surround us in our everyday lives. To begin today, we're going to decipher how the basic electric motor operates and then move on along to the different types of electric motors and how they work, specifically AC and DC motors. Let's start with the three basic terms of electric motors: electricity, magnetism, and movement. All have to happen to all work together for a motor to output work. This is able to happen through sending power through a wire that is wound in several different ways that creates an electric field, which is held above a magnet, which in turn creates movement because the way the electric field interacts with a magnet starts to spin the wire and continues to increase in speed, thus creating work. These are applications of Faraday's law and Lenz's laws. From the simple motors that you can build at home to the complex high output and efficient motors that you can buy off the shelves or that come in your electric and hybrid cars, electric motors come in all different manners of platforms. There are thousands of different kinds of electric motors. However, the easiest way to separate them is by the type of power they use, such as direct current and alternating current. Let's start with DC motors. As indicated by the name, it runs on direct current, which allows the rotor to spin inside of the stator. The rotor is a coil of wire which is connected to the electric power supply, and the stator is a permanent magnet or an electromagnet. These motors have the advantage of having more starting torque, faster starting and stopping of the rotation. Side note, which is great for acceleration in electric cars. They are also reversible, and they are capable of varying speeds compared to their AC counterparts. The few disadvantages is that they draw more power to start and require more maintenance throughout their lifetimes. There are two types of DC motors, one that is brushless and one that is brushed. As seen in the picture in this slide, the one advantage of a brushless motor is that it does not produce anywhere the amount of friction that a brush motor does. Overall, DC motors are found in everyday applications such as electric cars, toothbrushes, tools, appliances, etc. These motors are necessarily a necessity to the way we live today. To continue, AC motors are run off an alternating current. Unlike in a DC current motor, the AC current motor sends power to the outer coils that make up the stator and energizes them in pairs and in sequence, which allows them to create a rotating magnetic field, which in turn allows the current to begin to flow in the rotor because of Faraday's law combined with Lenz's law, which then in turn tries to make the rotor play catch up with the rotating magnetic field, causing work and power to occur. An advantage of AC motors is that they take less power to start movement and less maintenance throughout their lifetime. A disadvantage is that they aren't reversible or able to produce low-end torque. AC motors are often used in factories, pumps, water heaters, lawn and garden equipment, etc. These motors also allow us to live our lives in the comfort that we enjoy. These electric motors are a necessity to life. They allow us to have comfort in our homes and live day to day. From the moment you wake up and brush your teeth with an electric toothbrush to the moment you go to sleep when you turn on the fan at night, electric motors constitute a large part of our lives that may go unnoticed. It was truly a breakthrough in science when the first electric motor was created in 1834, as seen in the picture on the left, when the work of Joseph Henry and Michael Faraday was put to use by Thomas Davenport, and created the first electric motor before the light bulb was even invented. Thank you.